Hello there, everybody. Welcome to another course lecture on C++. In today's video, we're going to be going through vectors and arrays. Right. So to begin with, let's talk about vectors and how vectors work. So over here, I've actually declared a vector called double salaries. Now, a vector can be initialized with a data type of any type. For instance, this one I've called it a double. You can call it an int. You can call it a string. You can basically rename it the way you want it to. So the basic idea of this program is to enter in a number of salaries for employees. So as you enter in the number of salaries, the Boolean more will be set to true, and it will loop through. It will loop through each salary, and it will look for the highest salary, and it will label that as the highest value. So let's see how this works in practice, and yeah, let's run it. Right. So I'm going to enter a couple of salaries here. I think three is fine. And you can see it reprints the array and it says, okay, so the highest value that we have is 20,000 and that's the salary we're going to pick. So a couple of things to note about vectors, which I'll just show you right now, is that we use the function pushback to push a value into the vector. There's also another method called popback, which I haven't demonstrated here, which can actually remove a vector, move an element from the vector if you regard a vector as a stack. So I want to describe to you what's the difference between a stack and a queue in programming. Right, so here's a small notepad to show you to basically just to write out how it goes. So in a stack, we have value 1, value 2, value 3, value 4. In a stack, if we regard this section of the queue as the front of it, the very right side of the queue as the front of it, then every time you enter a value into this queue, say you enter a new value 5, then 5 will go there. Then when you enter another value, say you enter the value 3, it will go there. But when you remove from a queue, you don't remove from the front of the queue, you remove from the back of the queue. So, sorry, you don't remove from the back of the queue, you remove from the front of the queue. So the right side is the back of the queue, and the left side is the front of the queue. So say we add another number 7, that will be 7 added to the back of the queue. Now, if you want to remove from the queue, then you would be removing from this end. So say 1 will go into a new phase, 2 will go into a phase, 3 will go into a phase, then we're left with 4, 5, 3, 7. Now that's the order of how a stack works. So stack, we say, is first in, first out. That's the term we use. It's called first in, first out, or first in, first out, or otherwise known as FIFO. And the other option that we have is called a stack. So stack basically means um, last in, first out. So LIFO, last in, first out, last in, first out. So say for instance, in the stack, we insert the numbers 3, 4, 6, and 7. And we're inserting it at the right side of the list. Now, if we take out a value from a stack, we use popback, and popback is going to take out this value, for instance. I mean, it might even take out this value. So it only takes it out from the very beginning of the queue. It doesn't take it out from the end. Sorry, from the very beginning of the list. It doesn't take it out from the end of the list. So that's how a stack works in programming. Right. Okay, so in this example, what we're doing is we're entering a person's name. We can enter a name as many times as we want until we type 0, which will stop the while loop. Eventually, we get to this part where it says, which alphabet index do you want to remove? Pick A to Z. So say, for instance, I enter a number of names. I could enter my name, Darshan. I could enter another name, Chris. I could enter another name, Charles. I could enter another name, Amanda, and continue on until I've entered all my names. And then eventually, I'll type 0, and it will terminate the while loop. And then it'll ask you to enter an index that you want to remove. So say if I say C, then the names Charles and Christopher will be removed from the list, right? So let's actually test this out and see how it works. Okay, so it's asking me to enter a name. I'm going to enter my name, Darshan, Chris, Charles, Amanda, Dante, 0. And we want to remove, I'm going to say D in this case. So we put in D, and you can see it removes everything that starts with a D, with the letter D. So Darshan and Dante were removed, and we have Chris, Charles, and Amanda left over. So one thing I want you to notice about this is that you can get, so this function here, find, or what it's basically doing is it's finding an index in names. So the index that we found here is called IT, or index IT, which is short for iterative value. So we take it from names begin to names end. That's the length. That's basically the range where we want to find it. And then we have the actual value itself, names J. And then we take in when we get the index value IT, we put it into erase IT. We say names dot erase IT, which erases the value completely, and that minimizes the list as well, the vector as well. One thing to notice is that it's been declared as auto. Auto means it can be any value string into whatever. And another thing to notice about a vector is that a vector's size is not fixed. So when we get onto the next section, which is arrays, you'll notice that the difference between arrays and vectors is that an array cannot be resized, but a vector can be resized. So that's the difference between the two. So a vector is more can be used more dynamically than an array. Right. So in this case, we're actually set an array called cars. It has car brands or manufacturers such as Volvo, BMW, Ford, and Mazda. It's saying enter a manufacturer to remove. So once you've entered the manufacturer, so it first calculates the size of the array. So size of cars 0. And then before modification, the array is, so it prints what the array would look like before it's modified. Then we put in this, we size when we remove the element from the array. And finally, we print the array after it's been modified, and it displays the full size of the array. Okay, so let's look at this function called remove elements. So remove element has the following parameters. We have an array parameter called R. We have a integer parameter n and a string parameter x. The return type is an integer, and the name is called remove element. Right? So search x in array int I for I whatever is saying that we want to search x in the array. If x is found, then reduce the size of the array and move all the elements a space ahead. So what that means is that we're copying. So just now at the beginning, I've mentioned that when we look at removing an element from a vector, we have to copy all the elements from the start to the beginning if we use pop back. But we didn't use pop back, we used arrays. And arrays actually minimizes the size of the vector as well as removing the elements. So that's the difference between arrays and pop back. But in this case, for an array, we don't have we don't have an option to erase. We only have an option to copy the elements from from one step down to another and reduce the size. So that's basically what's happening over here. Okay, so if we run this and we try to test our code, you'll see it's entering the manufacturer to remove. I'm going to say BMW, BMW, And it says before modification array is Volvo, for BMW, Ford, Mazda. After it's Volvo, Ford, and Mazda. The full size of the array is 4. So you can see the size of the array, the actual size of the array never reduced. It still remained as 4. But the value of size, which we kept track of, which is this size here, would be changed to 3. It would be changed to 3. So that's the difference, right? So if we go back a few levels, and you can go back a few frames from this video, and you will see that for our vector, the size of the vector is always going to be adjustable to what's in the vector. It will never be like an array where the size has to be fixed. Okay, so that's basically how this part will work. Finally, part 4, we'll be looking at an array in 2 dimensions. So here's a small game that you can play. You can test out. If I put this code on GitHub, then you'll be able to test it out yourself. So how does this work? We've got a basically a bunch of pathways. So we've got 4 pathways, 1, 2, and 3. So a star represents cheese in a pathway, and a dash represents basically nothing. So the objective of this game is to guess where the cheese is in which path. If you get all the cheese right, if you find all the cheese, if the mouse finds all the cheese, then you're going to print you found all the cheese. If you, however, find a certain amount of cheese and you get caught, then it's going to print you got caught and found something amount of cheese. And if you find nothing, you find nothing. So the basic program and logic behind this is that we're using a multi-dimensional array. So we've learned over here um, we are setting a while loop. We've got caught equal to false and cheese found not equal to 6. So caught is set to false. We set it to true. Then we set it to false if we find cheese. If we don't find cheese, it stays as 2 and we exit the while loop. If cheese is found is equal to 6, then we know, okay, there's no more cheese, so we exit the while loop anyways, right? So if cheese is equal to 6, you found all the cheese over here. To print a multi-dimensional array, you've got to think of looping twice. In this case, we're looping in an index of I, and then secondly, we're looping in an index of j. So the first index is actually going through each layer of x. So 1, 2, 3, 4, each pathway basically, and then we're going through each j, 1, 2, 3, 4, and that is how the program will work. So let's run this and see how it goes. Right. So I'm gonna guess 2, 2. Okay, so I basically already lost. It says that you got caught and found 1 cheese. The remaining cheese on the map is part 0. There's 2 cheese remaining. Part 2, there's 3 cheese. Part 0, there's 2 cheese. Part 2, there's 3 cheese. And part 3, there's no cheese. Okay, so I've actually titled these wrong. I'm just going to correct that. I plus 1. Okay. Right, now let's see what happens if you find all the cheese. Right, 1, 1, 1, 2, 3, 3, 3. And it says you found all the cheese. Okay, and if we redo it one more time with the correction that I've made, part 3, part 3, part 4, it'll say you got caught and found 2 cheese. The remaining cheese on the map are in part 1, part 2, and part 3. Okay, so that's basically how a multi-dimensional array can work, and how a single-dimensional array as well as a vector works in C++. Hey guys, sorry, I made a couple of mistakes in this video, well, a few mistakes, but basically for Q, I actually called it a stack, but what it is it's actually a list that's meant to act like a queue. And another thing I want to mention is that whenever you declare a vector or an array, always remember that you're starting at index 0 when you're inserting an element or when you're working with elements within that vector or that array. Right. So that's what I wanted to just share with you guys. Hope that helps when it comes to programming. Always remember to recall that you're always starting from index 0, and the index that you're ending at is size minus 1, which is size is basically the length of the array. So if there's 4 elements in the array, it'll be 0, 1, 2, 3, but the size will be 4, and if you want the last element, it'll be size minus 1. Okay, thank you guys so much. See you guys. Right. I hope you guys enjoyed this lesson. If you want more of this, please please view the videos. Please subscribe and comment if you feel that you need any help with anything. If there's something you don't understand, just comment below. If there's something you want from this course that you really look forward to in C++, then also comment below, and I'll definitely assist you on all of that. Right. Thank you so much, guys, for watching this video. Until the next lecture, Darshan out.